Hi guys, myself Sadashva. Today let us discuss about the partition methods of clustering k-means. Welcome to a deep dive into the world of clustering, a fundamental technique in the data analysis and machine learning. We'll explore the k-means algorithm, its core components, and how it is used to organize the data into meaningful groups. Introduction to clustering. What is clustering? Clustering is an unsupervised learning technique that groups the similar data points together based on their characteristics. It's used for various applications from customer segmentation to data analysis. Key concepts. The main goal is to find patterns in unlabeled data, allowing us to discover hidden insights and creating meaningful clusters. K-means is one of the most popular partitioning clustering method. What is K-means clustering? Partitioning method, iterative algorithms, and distance-based iterative algorithms. It assigns the data points to clustering based on their distance to cluster center. It repeatedly updates these centers until coverage, uh, meaning minimal changes in clustering algorithms. Distance based. The algorithm determines which cluster to be belongs to by measuring its distance to each point and assigns it to the closer one. Key components of k-means. Data points. These are the individual piece of data you want to cluster, represented as points in the multi-distinction space. Cluster center. These are the central points of each cluster, representing the mean or centroid of all data points in the clusters. Distance metrics used to calculate the distance between the data points and the cluster center. K-means algorithm. Randomly initialize K cluster center. Assign each point to nearest cluster, each based on the distance metric. Recalculate the cluster center as average of all data points assigned to the cluster. Repeat the step 2 and 3 until the cluster assigns the value to center stabilize, indicating the coverage. Choosing the number of clusters. ELOP method. Plot the within cluster sum of squares again the number of clusters. The optimal K is where WCSS uh, curve starts to flatten, forming an ELOP shape. Advantages of K-means cluster: simple and efficient, scalable, widely used, and versatile. Simple and efficient, easy to understand and implement with relatively low computational cost. Scalable, can handle large dataset efficiently, making it suitable for many real-world applications. Widely used, a popular and widely used algorithm, making it readily available in various software libraries. Versatile, applications to a wide range of data types, and it includes the customer segmentation, image, and document clusterings. Limitations and challenges. Sensitive to outliers, initialization dependency, assumes spherical clusters, requires determining K. Sensitive to outliers. Outliers can significantly influence cluster centers, leading to skewed results. Initialization dependencies. The initial placement of cluster center can affect the final clustering outcome. Assumes spherical clusters. K-means assumes the clusters have the spherical shape, which may not appropriate for the data with complex structures. Requires determining K. Choosing the optimal number of the cluster can affect the careful analysis and the experimentation. Applications of K-means clustering. Customer segmentation. Grouping the customers into distinct segments based on their purchasing behavior, demographics, and preferences. Image compression. Grouping similar colors into an image to reduce the file size while maintaining the visual quality. Anomaly detections. Identifying the unusual data points and the significant form of normal fraudulent activity or system failures. These are the applications of k-means clustering. Conclusion and key takeaways. K-means clustering is a powerful and widely used algorithm for partitioning data. By understanding its core components, advantages, and limitations, you can leverage these methods for variety of data analysis and machine learning tasks. These are the conclusion and takeaways. Thank you.